Hi everyone, Nick here. We're back again to talk about the third piece of the puzzle, which is surface interactions. The two dimensions of surface are depth and breadth. And you can kind of think about this as, think about a body of water like a pool. The pool is going to have some amount of width to it, and it's going to have some depth as well. And that's what we're going to try to measure here. When we talk about depth, we're talking about how tightly coupled two different components are. So for example, segment routing, a brilliant new technology for stateless MPLS traffic engineering. I'm a big fan of it. But it's tightly coupled with IGP. So OSPF and IS to IS currently support segment routing today on many platforms. Very, very tight coupling between prefix advertisement and label advertisement. They're basically married together in the same control plane now. I would consider that to be a very deep interaction with IGP because the two are so tightly coupled that they don't really operate independently. Contrast that with label distribution protocol, which has been around for much longer, where we run this almost overlay protocol, a separate control plane that says, for every route I've learned from IGP, I'm going to allocate a label for it. LDP works with any routing protocol except BGP. So it works with the EdgeRP, it works with RIP, it works with static routes, because it doesn't have a tight coupling with IGP. And in fact, I would use the word shallow to define the depth of that relationship. So segment routing has a deep interaction with IGP, very tightly coupled, while LDP has a shallow interaction with LDP has a shallow interaction with IGP. They're almost like ships in the night. They cooperate, but they don't directly rely on each other and the protocol specifics. The second dimension is measuring breadth, so kind of width, if you want to think of it that way. A good example, a simple example here is doing redistribution. Doing redistribution at one point in the network, there's typically not a lot of cause for loops with that. Maybe I've got EdgeRP and OSPF, and I'm just doing a simple redistribution between the two. I would call that a narrow interaction, kind of like a narrow channel where there's not a whole lot of, we're not doing it in lots of places in the network. Now imagine that instead of just doing that redistribution at one point in the network at your corporate headquarters, you're doing it across all 100 of your branch sites, redistributing between EdgeRP and OSPF. That would be a very wide surface interaction because we're measuring across the network how often are we doing this and what is the impact of that. So these two dimensions are going to come into a little bit better focus when we start to look at some more examples. Another way to think about this is in terms of process steps, and this is something that is common in the DevOps environment and something that I've been very interested in for those who follow some of my podcasts, is anyone who's ever read the book The Goal, which is one of my favorite books by Dr. Goldratt, he talks about two concepts there, statistical fluctuations and dependent events. And if we have these three processes, so in this case, I've got three rows, maybe three different lines of tasks that need to get done, and the percentage in those boxes represents the probability that the task gets done right the first time. Now, variations in this process, they don't just average out over time, as some people might think. So for example, you might look at those lines and say, well, the average of those three numbers is 92%, which means that each line produces the correct component 92% of the time. That's actually not correct. To get the real percentage, you'd have to multiply these three percentages together, and you'd end up with something like 73%, something much, much lower. Why is this even relevant? Why do I even bring this up? The reason is because surface interaction is all about dependent events between components. So each one of these, if we look from left to right, the longer that chain is, the deeper the surface interaction. More dependencies means deeper interaction. And then the number of places that we're doing it. So maybe I've got three different assembly lines where people are putting things together. That would be the breadth. So I have those two arrows, and I'm going to use a similar kind of diagram like this to describe some other technologies to help make it clear. But I want you to kind of think about depth and breadth in this way when you look at the components of a process. And we're going to look at some network examples as well as in how many places are we doing it. Back to our favorite example with IntServe. When we think about depth and breadth of the two styles, let's talk about IntServe first. The client application has to run RSVP, and all the routers in the path has to run RSVP too. Now, technically, core routers don't have to run RSVP. There's a technical mechanism to do RSVP across non-RSVP routers, but that's not really relevant to this conversation. I would consider that to be a very wide surface interaction because every device in the network, including the phones, has to speak some kind of RSVP style communication. Everyone needs to speak this language in order for this QoS strategy to work. I would also consider it deep since the host is reliant on RSVP to honor the reservations. So for example, the host is saying that the host can't just send packets into the network and mark them and have the devices treat them based on per hop behaviors. The reservation that comes back, the host is assuming that that reservation has been made and that the bandwidth is available. So this is a kind of a new dependency. Maybe not the deepest surface interaction in the universe, but deep enough to warrant some consideration. And if you want to think of it kind of at a higher level, instead of just RSVP as a technology, the entire business is counting on the design to work. Or else their applications perform poorly and the company can't run its operations. So you might think about the dependency even reaching up into the stack, if you will, up to layer 8, where the business aspects start to come into it. And the depth of the surface interaction can include them. We're not going to get too much into that because it can get these somewhat objective conversations can get subjective really quickly. So we won't go there too much, but I did want to bring that up. Let's look at RSVP from just some basic protocol messages, breadth and depth. So if we think about the previous diagram where we had RSVP, I have to send my path message from the sender all the way to the receiver. So that's going to make its way from left to right across our test network. The reservation network or the reservation messages are going to flow back the same way. And then my traffic flow. So why did I draw the graph this way? Well, you think about the message process. First, I need to do my signaling forward, and then I get the reservation back, and then the flow can finally start. I would consider that to be the depth of the operation from the host through the network and all the messages entailed. The breadth of the operation is how many devices need to process it. Well, in our network, we only have 3 devices, so I'm showing each one of these rows would represent a network device going through the steps in the process. Now, I realize that this chart is a little bit abstract, but I wanted to show an example since we've been talking about InServe for a while on how it would fit into that. Fit into this model. Surface interactions can also overlap. This is probably the simplest example. If you think about 3-way route redistribution on a single router, it's really easy to visualize and it can be neatly drawn as 3 different bubbles all interacting in different ways at a single point. This may not be relevant for all assessments though, and when we look at some of the assessments that I've done, I didn't find a lot of overlapping surface interactions, but I did want to bring this up because it is possible that you could have multiple things interacting. I know I said earlier that the depth is measuring the surface interaction between 2 things. I did that mostly as a simplification. It can certainly be more than 2 if there are multiple interactions at one particular device. Viewing it as a chain of steps though, as we looked at the previous slide, can be good to try to see in your mind's eye how the process works, but do keep in mind that there could be multiple overlapping surface interactions. This example is really easy, but let's look at a more complicated one because this is something that is pretty common in the carrier space, so I'm just going to describe it for those unfamiliar. The idea of this design is I have a client, let's just follow the numbers, that's probably the easiest way to do this. Client says, I want multicast, and that looks like an AnySource multicast group. So I'm expecting to find a rendezvous point and go through all the fun PIM, ASM stuff. First hop router, instead, we're going to use a feature called SSM mapping where the router is going to ask a DNS server, hey, I have a client who wants this group. What sources do you already know about that are sending to this group? So I asked the DNS server that. The DNS server comes back and says, I know about one source and there's its IP address. So this router, the last hop router connected to the client, will send a S-G join back towards the source. Now, if you're not a multicast expert, don't worry about it. But what I'm really getting at here is there are some overlapping surface interactions here. So for example, when we use DNS in this way, normally egress routers are only responsible for basic PIM control plane activities plus forwarding. But in this case, now he's also doing a DNS lookup plus the PIM interactions and IGMP to the client. So we've added a new surface interaction. We've added DNS to the PIM control plane. I like to think about it as a new dimension or a new wrinkle into the mix. And we need to consider this new surface interaction as well because it's part of our control plane now. Now let's get into the examples of intentionally increasing surface interactions to decrease state. So we're going to come back and talk through segment routing here. This is the example I'm showing here is a good example of segment routing. So suppose we had some large global ISP, been using RSVP traffic engineering for 10 years, it's been incredibly successful, but maintaining all that per LSP or label switch path state all through the network, along with all the soft state refreshes that RSVP needs to do, that became costly. So again, the state plus the speed of state equals wasting money. That's bad. ISP plans to migrate to segment routing by embedding MPLS labels in IGP. So like I've shown on the screen, I'm sending my IS to IS link state packets around. I've got prefixes for my device loopbacks, but I also have local labels allocated. Again, without turning this into a segment routing course, this allows IGP and segment routing to be fused together in a tightly integrated design or tightly coupled design. I remove all my core state for LSPs, but the surface interaction changes a little bit. So the new increase in surface interaction that didn't exist before, because IGP and RSVP were two different things, I now have a surface interaction that I would consider to be shallow but wide. So why do I call it shallow but wide? Well, coupling segment routing and IGP, that's a tight coupling between those two things. I would still consider it relatively shallow in the grand scheme of things, and we're going to see on the next page why that is, and I have a diagram to show it. But I'm calling it wide because everyone in the network has to run segment routing now. Now again, yes, there are transitions where that doesn't have to be true, but just bear with me and assume that our enormous 5-router network is running segment routing. This diagram should help explain it a little bit better. Each row here represents one of my routers. I have segment routing and IGP and a coupling. That coupling may be tight, but it's not very deep because it's only 2 components. So I have a router that runs segment routing and IGP times the number of routers I have. This is why I called it shallow but wide. So hopefully this diagram makes a little bit of sense on how we can analyze the complexity of segment routing with respect to surface interactions. Let's look at another example, this time in the enterprise space. So for those who don't like carrier technologies, this one's for you. This is intentionally increasing surface to decrease de-optimization. So put another way, we want to increase surface interactions. We're willing to take on more surface interactions to make a network that's more optimal. The example here is direct internet access, or DIA. So suppose I've got these 3 routers out there, and of those 3, I've got only a few that need direct internet. Let's say 10%. So this is just a sample. Let's say I've got a couple hundred branch sites. Most of the routers act like the 2 on the left, where they tunnel all their internet centralized back over those gray WAN tunnels. Let's just call it, some kind of IPsec VPN, back through the head end where they have a firewall. So the centralized internet gets backhauled. There's no firewall at the branch sites. They get inspected. They go out to the internet. Everyone's happy. But at a few sites, we have direct internet access. Why might we have that? Well, maybe those sites need direct access to the cloud for some kind of modern application, or maybe it's just a pilot to see if DIA is right for this company, so they do it on a subset of their sites. However, maybe they have some specific security requirements where they need to do things like TCP session clamping, deep packet inspection, state retention through firewall inspections, real-time logging, HTTP URL filtering. I'm just making up a bunch of security stuff now, but let's just pretend we need to do that at all our sites. I would consider this increase to be deep but narrow. Why do I call it deep but narrow? Well, if we look at this picture, it's kind of the opposite of the one we saw for segment routing, where the depth is very, very long. In order to do DIA, I have firewalls, I have TCP clamping, I have deep packet inspection, logging, and URL filtering. Yowza, that's a lot. But I'm only doing it at a small subset of our sites, let's say 10%. So if I had 20 sites, 2 of them would be doing this, but it wouldn't be done everywhere. So this new surface interaction for DIA could be considered deep but narrow. So you can kind of see how these trade-offs work. Now, of course, you can have things that are deep and wide. For example, if we were doing DIA everywhere, that would be deep and wide. Just to show that it's not always that you're going to end up with such a lopsided rectangle like what's here. You might have something that looks more like a square if you had a pretty equal amount of depth and breadth. But I just wanted to show a couple examples. So that is the end of the course. Hope you've all enjoyed this. Please let me know if you have questions, and we will talk some more in the future. Thanks.